So this was a fun little criticism of my promotion on the facts of nuclear science and technology in terms of their application towards nuclear energy. And the reason why is that this is actually going to require a little bit of statistics to understand how this person is abusing the laws of statistics to come up with their own narrative. And that's pretty easy to claim, but let me walk you through it because it is actually kind of interesting when you think about it. To start off with, this person is trying to claim that a nuclear meltdown is not the worst thing that can happen with a nuclear reactor. Well, the laws of physics would disagree. What happened with Chernobyl, where you have a nuclear meltdown and then a fire to loft it up into the atmosphere, yeah, it's not going to get worse than that, unless you do it intentionally, like with a nuclear weapon, for example, where you intentionally distribute it as much as you physically possibly can. But a nuclear reactor cannot detonate like a nuclear bomb. A nuclear bomb requires dense fissile metal that's got to be compact, and that's not how you build a nuclear reactor. Nuclear reactors have coolant. You got to get the heat out and structural materials and moderator and all of these different things that prevent you from having this compact, tiny little fissile material that you can make go prompt critical like that. So it's not even possible to do worse than just the simple nuclear meltdown, as simple as that might sound in that argument. The argument that's actually being made is that you don't know the tails. So the tails requires you have to know the distribution. Now the distribution means how far above the average and how far below the average are you likely to have, right? What is the average of some kind of outcome, like a nuclear accident or whatever the case might be? And the problem with this argument is that the uncertainty with the tails is really the uncertainty for anywhere in the distribution. Now there is this thing called the law of large numbers where your average is going to attain the population average. And then there's another theorem in statistics that tells us if I'm taking averages of samples, they're going to be distributed according to a normal distribution, meaning it's going to look like a bell curve. And so once I have the average, there's going to be some deviation around that that's going to have this nice functional form. And that functional form also has tails. Well, asymptotically, it will become normal, but there are going to be deviations in the entire distribution. It's not just the tails. And so if it is normal, then that's the way it will behave. It might behave like something else. And it's simply the empirical outcome that you're going to get is generally going to have some functional approximation. But the argument still is simply saying, well, because you don't know everything, it could be far worse than you're saying. And technically, that literally applies to everything. You watching this video right now, if you really are going to take that to the extreme, you don't know your phone's going to blow up. You don't know that your seat's going to light on fire, or whatever the case might be. And so we don't want to become ridiculous making these arguments that since you don't know everything, you can't do anything. That's insane. Well, I hope that helped. Let me know if not. Thanks.